Hi, welcome to Math Videos, and today we are going to learn about the different types of angles formed by the transversal with two parallel lines. Let's start with a couple of lines that are in the same plane. These lines are called line AB and CD. Now, the important thing to note about these two straight lines is that they are pointing in exactly the same direction. So, even if we extend them forever, they would never cross. When two lines are arranged like this, we are called them parallel. You have probably heard the term parallel before, like parallel parking or parallel bars. Here, the two lines aren't parallel. In fact, they cross at this point. Let's name it point P. When lines cross at a point this, we say that they intersect, and we call the point an intersection. And when lines intersect, they form angles. We think of the angles as the space that are formed between the intersecting lines. These intersecting lines form four angles. 1, 2, 3, 4. Consider line P and Q, which are on a plane, and they aren't parallel, and this is a transversal R, which cuts the lines P and Q at 2 points. The transversal form four angles with line P, angles 1, 2, 3, and 4, and four angles with line Q, angles 5, 6, 7, and 8. Angle 1 and angle 5 are corresponding angles. Now, let me ask you an intersecting question. Look at the figure. Is this the only pair of corresponding angles? No, we have three more pairs of corresponding angles. Angle 2 and 6 are corresponding angles. Angle 3 and 7 are corresponding angles. And angle 4 and angle 8 are corresponding angles. So, these are the four pairs of corresponding angles that are formed. 1 and 5, 2 and 6, 3 and 7, 4 and 8. Angles 3, 4, 5, and 6 are interior angles because they are between the two lines, and they are classified into two types. Let's understand the first type. Angle 3 and angle 5 form a pair of alternate interior angles. We know why they are called interior, but why exactly are they called alternate? That's because the two angles in the opposite side of the transversal. As similar, angle 4 and angle 6 are also called alternate interior angles. This was the first type of the interior angles. The second type is a pair in which the angles are next to each other on the same side of the transversal. Like angle 3 and angle 6, they are called consecutive interior angles. Look at the figure now. Do you see any other pair of consecutive interior angles? Yes. With the same logic, even angles 4 and 5 are consecutive interior angles. And the last types that are formed are vertically opposite angles. Angles 1 and 3 are called vertically opposite angles. In all, there are four pairs of vertically opposite angles. 5 and 7, 4 and 2, 8 and 6. And vertically opposite angles are always equal in measure. Here, consider line P and line Q, which are on a plane. The lines are also parallel to each other. If line P and Q are parallel and R is a transversal, then each corresponding angles are equal in measure. I mean angle 1 equal measure of angle 5 and measure of angle 2 equal measure of angle 6. Measure of angle 3 equal measure of angle 7 and measure of angle 4 equal measure of angle 8. And each alternate angles are equal in measure also. So measure of angle 3 equal measure of angle 5 and measure of angle 4 equal measure of angle 6. So if lines P and Q are parallel, then each two consecutive interior angles are supplementary. So what is the meaning of supplementary? Supplementary, I mean the sum of the two angles equals 180. So measure of angle 3 plus measure of angle 6 equals 180 and measure of angle 4 plus measure of angle 5 equals 180. Okay? On a new page, let's look at the beauty of these angles. Assume we have line A and B which are parallel and transversal C which intersected them at 2 points. As we already know, the transversal forms 8 angles. 1, 2, 3, 4, 5, 6, 7 and 8. Let us quickly analyze the relation between various angles formed. It's pretty simple actually. Angle 1 will be equal to angle 5 as their corresponding angles, and angle 7 equals angle 5 and it is vertically opposite to it. And angle 3 equals angle 7 because they are corresponding angles. As similar, angle 2 equals angle 6 as corresponding angles. Angle 8 equals angle 6 because they are vertically opposite angles. And angle 4 equals angle 8 because they are corresponding angles. So, if lines A and P are parallel, we can see that angles 1, 3, 5 and 7 are equal in measure and angles 2, 4, 6 and 8 are equal in measure.